Hi, welcome to Cloud Cover. My name is Ryan Dunn.
And I'm Steve Marks.
The show today is going to be on routing within Windows Azure. Now, routing is a topic near and dear to my heart. My early family, when they came over to this country, they were routers.
That's what it is, yep.
Actually, I have no idea.
You changed your name. Your name used to be Ryan Routerson.
Router McDougan.
Right, so Ryan's family has a rich history of routing. The rest of us just occasionally need to route TCP connections, or usually HTTP connections.
Maybe that's what it was.
That's what your family did back when
got it confused.
Came to this country.
Yeah.
Back in the 1800s.
Something to that effect.
ASP.NET routing, that's what they did. So we're going to be talking about that. We got a tip of the week that is basically, as many of our tip of the weeks are,
is based
off
the
stuff that we messed up putting together the samples.
Exactly.
So we got a tip of the week that's useful for people who are launching processes within Windows Azure. Mm-hmm. But before all that, we should probably cover some news. This just in, Ryan's family is routers.
What did I say? Router McDougal?
Router McDougal.
Router McDougalsons. All right, so first on the list, we have an AG Azure Development Storage Proxy. I'm going to go AG stands for Silverlight.
Yep. Silver, it's the symbol on the periodic table.
Correct.
For silver.
Mundo JJ.
That's how you know.
Yep. So this is kind of neat. I ran across this because I frequently scan Codeplex looking for cool Azure projects. And this one stuck out because it claims to solve the issue of the cross-domain policy file.
Right. So if you've ever...
You are familiar with this.
If you have ever downloaded a sample from my blog and tried to run it locally using local development storage, there's a good chance that you've hit this very issue. Because all the samples that I've done with Silverlight that require this cross-domain access to storage, so like the Netflix pivot sample and... way back when I did that Silverlight blob uploader thing. None of those things work when you run it against dev storage, and it's because of this very simple issue, which is that the URLs look different in development storage, and specifically, they have the account name in the URL. So while in the cloud, it's myaccount.blob.core.windows.net / whatever, container, blob, etc. And specifically for client access policy, it's just client access policy XML in the root container there. When you run it on development storage, it's 127.0.0.1:10,000 / dev store account 1, so that's the account name, / and then everything else, which means that's where your client access policy ends up, which means it's not at the root of the server, and that's where Silverlight looks for it. So if Silverlight is trying to make a connection to localhost : 10,000, it'll look in the root for client access policy. There's no way for you to get that XML file in the root using development storage because of the way the URIs work. Until this Codeplex project, which, as I understand it, is a proxy, hence the name.
I have not tried it. However,
so we don't know if it works.
I'm guessing it claims to fix this particular issue. Now, there's two ways of fixing it, right? One is you kind of trick it so it looks like it's the root, and you route to it. Or two, you just rewrite Silverlight so that it can use cross-domain policies wherever you like.
Yeah.
I'm going with the probably did the proxy solution as opposed to rewriting Silverlight.
There's good reason to believe that's what happens, right? So presumably this is on some other port on localhost. It gives you development storage, but it also, if you do / client access policy.xml, it just works and sends back the
I think
right
it forwards it.
That would be my guess. That's a good solution to this problem. Fixes all the samples on my blog. So awesome.
There you go. Now the next one comes from the Sync framework team. So Leon Kavanaugh, who is Mr. Sync. We'll call him Mr. Sync.
Okay.
I believe his name is actually Liam Sink Kavanaugh.
Middle name is Kitchen.
Kitchen.
It's actually Liam Kitchen Sink.
So he has a post out on Channel 9. Actually, he did a webcast, but I like the blog post a little bit better because you can view the code more easily. Where he covers using the sync service to sync SQL Azure with your local SQL server, which is a pretty common thing that people want to do. Turns out SQL Server and SQL Azure have a lot of things in common. In fact, they are both versions of SQL Server.
Yeah.
So you can do this pretty easily. Now, there's a few tricks in here, and Liam highlights it. The code is out on the blog page. It looks pretty easy, actually. It's like 10 lines of code or something like that. Most of it is just console write lines. So I'm assuming that this is nothing too difficult. But very cool regardless. go check it out. We'll have this linked up on the post itself. Now, the next one I ran across was on the Twitter spheres. Someone claimed that Humphrey Scheel from the United Kingdom is where he is located currently right now. According to this blog post, it says right now he is in the United Kingdom. I'm assuming this changes as he moves around the country. Now, Humphrey has installed Umbraco CMS, which apparently is a good CMS system.
And we got a question, actually, when we did our Twitter questions show sort of thing, we got a question of what CMS can I use in Windows Azure? And so
this is why
this is one answer.
Stuck out for me. I was like, wow, I should probably cover this. So he got it installed, and apparently, other than some minor misunderstandings I think he had of how diagnostic connection strings and things are set, other than that, it didn't look like it was too bad. I mean, essentially, he just used the SQL Azure migration wizard to migrate from SQL Express to SQL Azure, and then pretty much everything ran.
So did he run it locally, and then to set up the database and whatever, then migrated the database?
It sounds like it,
and then move the actual app.
Now, what I don't have in here is whether or not he's really tested to see if this works in more than one instance, like in a load balance environment. I'm not sure what Umbraco uses in terms of session management and whatnot. So what I don't see is if he's actually done this or not. So it'd be interesting to see. Now,
cool.
Next one is getting started with the Windows Azure CDN. Now, the CDN, as some people are aware, is our content delivery network. This is our edge computing, or edge servers, located 20 locations around the world currently.
And growing,
growing
by the hour, because every time I hear the number, it's like one
21.
higher than the previous one. So.
In fact, I'm just going to go ahead and say we have 21 locations, because we're guessing that it's probably already changed.
Well, this show isn't going to air. We record a couple days before the show actually goes out on Channel 9, so maybe 23.
Preemptive 25.
25, all right.
Okay, now,
we're going with 25.
Currently, we say 20, but it could have changed at any moment. So to get started, it's extraordinarily easy, and this MSDN post actually outlines what it is. So, it's basically go out to the portal, click a button, upload some blob content, set some time to live headers, and wait for it to propagate.
It's a pretty long article for go to the portal and click a button.
It is, and what most of it is this little code snippet which shows how to programmatically script out access to create the actual storage account and then set the time to live. In this case, max age 315 36,000. Which means
what number is that? That's
I don't know, it's like
forever.
It's like a year.
It's in seconds, right? So
it's like a year or something. I forget.
Right. I believe you.
Yeah. Anyhow, it's easy to get started. Here you go.
We've got the security resources.
The souses of security.
There's a missing R in the title of this page.
We have high quality control standards here on
we
MSDN.
spell check almost all the pages we put on MSDN.
Especially the titles.
So we've got security resources here. You know what? I bet that's because it's actually, I don't know, I have no idea what the workflow is, but I bet the title is in a completely different place than the document with the text, which is probably edited in Word or something where spell checking is done.
Underlined.
But the title is like some guy types it into the thing on a web page and just go. So anyway, we've got security resources here for Windows Azure. It's basically a collection. It's just a one-page collection of all these different white papers that we have for Windows Azure, for SQL Azure. There's some identity stuff in here. There's some storage stuff in here.
And the reason we're really talking about is because we've highlighted 2 episodes that they're covering.
That's really it. That's how people, if you want us to cover your stuff on the show, just put links to our show in it, and then we'll happily talk about it.
Or send us free stuff.
Yeah, free stuff. We accept bribes.
I will totally gladly wear your logo if you have something, assuming it's not a tattoo.
Do that.
Yeah, you want.
We should sell all this advertising space.
Look, I'm a white board here.
Blank slate. Tabula rasa. So a lot of these are resources that you may have already seen or have been talked about before, but I bet there's at least one thing on this page that you never saw before because we didn't have one page that made it very easy to find all these things.
And there's some other stuff. This is always growing too. I mean, as more content comes in, like the Windows Identity Foundation or WIF guidance, for instance, that will get added, more content like that as it comes around.
People keep coming. The next update is supposed to be a couple days before you see this episode. which means it may already say resources.
Yeah.
Then
it's
we're going to
not-
seem stupid, huh? Because we just made this resources.
No, because look, we've highlighted it.
Okay, there's proof. Video proof that it said that
It says Souses.
at the time of this taping.
All right.
Great.
I think that's it. Let's talk about our feature.
Yes. Routing.
Now, the feature is routing, which my ancestors did. They were routers. I don't know why.
You know, there's a woodworking sort of routing too.
Yeah.
So that's like a totally legit. It could be that's your
what they did.
family of woodworkers.
Not so much.
No.
But
Anyway,
yeah, the feature is routing, and why do we have to have routing, or why is routing useful? This comes up a lot, and it usually falls into a few categories, which is I don't want to rewrite my app, and I need to get to a specific machine. I'm doing something bad in my app, and I'm carrying a lot of state in one location, and I refuse to buy into this whole cloud model where we should be stateless. Or
okay, no, this doesn't have to be that bad, right?
or sometimes for other reasons, which is like, well, I have some multi-tenancy things where I have groups of similarly configured machines, but I have customers located in specific sets of machines.
Yep.
And so I have a true multi-tenanted resource, but I need to route to a specific set of machines.
Yeah, and this can be. I've seen apps where it's just like a hard requirement, like, well, no, this guy's connected here, and we need to get on the same box so that they can talk or whatever. But more commonly, I've seen it as an optimization. I mean, it's more likely to be I'm in the midst of some big process that this guy's doing, and when he comes back to the website to change something, I don't want to have to go to a different machine, transfer all of that state that I'm doing. So it's often a performance optimization, or I've cached all of his stuff here already. Why do I have to go load it up again on a different machine?
True.
And so I'd like to get routed back there. If it doesn't happen, it's not the end of the world, but it would be really nice if I could do that.
I was being somewhat
the reason why it's
facetious
important,
about that.
actually, that if it doesn't happen, it's not the end of the world. The reason that's important is because, of course, any one of these instances may just die at any moment, because a hard drive fails or something else,
Or your app crashes.
Or you're in the middle of a software update, and that means that we're rolling out some other version, and so this might go down and come back up, and it may not come back up on the same exact VM on the same machine. It might be somewhere else. So there are lots of issues here. You might be scaling or whatever. So you can never rely on that very same VM that you were talking to before still being there. But if you can do it as an optimization where, well, if it's there, I'd really like to do this work there because I've already done a bunch of the work and it's all sitting on the local disk, But if not, I'll land somewhere else and that guy will just have to load it up and do it. Correct. And so it should always be as an optimization. So think of it like caching, think of it as sort of a performance optimization. That's going to be the more common use of this.
Yeah. I think we should probably draw a picture of how this kind of looks.
Let's do it.
I'm going to draw this. And my drawing skills are enviable.
Superb.
So, yeah. No, enviable. Like you actually have envy from my drawing skills. I can tell.
Okay.
Not so much.
Yes.
Okay.
I
there
envy
we
them
go.
already.
So we have people.
I
and
stopped envying them.
These people. What?
That was it. That's as long as my envy lasted.
Well, this guy who's always happy.
Oh, now I envy them again.
Yeah. He needs to get to your service.
Yes.
Now you have a service located in the cloud. I could draw it as a big fluffy thing over here, but you make it an imagination that this is the cloud. Now your service lives over here on many different machines. Most likely. You could have a single instance, but most likely you have multiple machines actually running your service. And to all the world, your service kind of is exposed at a particular VIP address and a load balancer. So if we made the load balancer look like this, your service is exposed here. So when somebody makes a request, it's going to go to a particular port, a particular IP address, and then this in turn is going to round robin that, assuming that these services were hosted on each instance, it's going to round robin that to each instance within your service. Now, for your user's perspective, when they make this request, in fact, they could be, for reasons like Steve was covering or we said earlier, they could be wanted to get to a particular machine. You might have a little bit of this user's data stored here. It could be session state, or it could be the case where this person is part of some organization, for instance, and you've decided that this organization is only going to live on these two servers. So you're going to multi-tenant this service, but you're going to make it kind of a chunky multi-tenant within batches of your service. So all the other smaller organizations are on these services, or these servers over here, and maybe you have more of them. But big organization gets maybe 2 dedicated, or it's on some set of servers, and you need to get to that particular set of machines.
Right, so it's either about some state or some caching, or it could be, in this case, about basically resource allocation. Like, this guy should be using that resource, so let me route him there.
Exactly. And again, like we said, this could be session state. Maybe we need to connect to this machine because other users are connecting to that particular machine at this point in time, and you want them to connect to each other within the app, could be a chat, something like that. So there's a reason why you're going to want to get to this machine. Now, if you look at the diagram as it currently stands, you see that there's a problem. We are going to load balance you, so there's really no way to tag the incoming IP packet to say, go to this machine exactly. So the way we fix this is we introduce a router. And the router really stands right behind the load balancer. So right where this service is, we're gonna go ahead and create another service. And your services will still live on all these machines as individual copies of the service. And you don't have to, but you'll probably only expose them on internal endpoints. So these horrible looking little things with sticking out, this is like an internal endpoint, maybe on port 20,001, something like that. It's just assigned randomly.
Enviable drawing skills.
Yes. So there's the port for these machines sticking out like little antenna. And you can tell how awesome that is.
Right.
Now, the routing service, however, it's going to maintain some state, or it's going to have another method of inspecting how to route to that particular instance. Now, in one case, you could have a user come in, and they're going to have these HTTP headers. Let's assume it's HTTP for now. Now, obviously, you can use TCP, some other things, but it gets a little more complicated. HTTP has some headers on every request. So the first thing it says is, HTTP 1.1 get some resource. Then it tells you about what it'll accept, some content types, and eventually it also comes back and tells you what cookies it has after you make the connection, and these cookies get set. So it'll tell you, for instance, if it has cookies. Well, what you can do is if you write a routing service here, so this is the one that's hooked up to the load balancer. This is the only one that's hooked to the load balancer. When a request comes in, if this routing service is clever, it can go look into these HTTP headers, and it can figure out, aha, I've seen this person before, there's a cookie in it, or whatever logic you want. It could be host headers, it could be IP addresses. There's some business rule, essentially, that tells it, oh, I've identified this user versus this user, and you can differentiate them. And then it's going to go ahead and it's going to connect up network streams, essentially, underneath the covers, and it's going to forward this traffic to the internal endpoint, wait for the response to come back, and then forward that back out as if the connection occurred through the load balancer directly to the machine. Now, it sounds easy to do. In practice, this can be as complicated or as not complicated as you want. You could do, like I said, you could say, well, I've seen this IP address before. Every IP address that I see that comes from this guy, send them to this particular instance. That could be the rule. Problem, of course, is if this guy's sitting behind a NAT and every single person appears in that organization to be coming from that IP address, you're going to be sending a whole bunch of users to a single instance. So sometimes you need to get a little more granular than that. Now, to talk about this a little bit more, I'm going to show you some code that I wrote. And the code is actually used for HTTP-based sticky session management. What we do in this code is we set up a socket listener, and we wait for a request to come in over from the load balancer. And just like I mentioned, we look at the HTTP headers. We specifically look for a cookie set, the standard one you get from ASP.NET. And then it remembers that cookie, and it forwards you, first randomly to an endpoint. And then secondly, it matches that kind of in a hash table in memory and says, look, I've seen this cookie before. Every time I see this session cookie, send it to the same instance. And you get this kind of sticky session load balancing behavior.
Right, so before you have a session, there's no cookie. This thing just randomly routes, which is basically the same thing you'd get if you just used load balancing in Windows Azure as
Exactly.
is. As soon as the cookie's set, now this starts to do the logic of intelligently always routing the same session back to the same instance.
Exactly. So let's look at this first. The core of it is really this TCP router, and what it has is there's a listener on here. So the socket server starts, and then it hooks up an event called client connected. So every time we get a connection, this event's going to fire. Now the client connection itself is pretty simple. Once the connection happens, the first thing we need to do is get the remote endpoint, or where is this connection going to go. The logic to do that can be more specialized. In this case, the specialization logic is the piece that looks at the HTTP headers. So I'll kind of show what that looks like.
Right. So this could instead just be the IP address, as you said, or
yeah, it could be anything. In this case, this remote get endpoint, what it does is it actually peeks into the incoming connection, and it pulls out those. So it goes ahead and it reads the headers. And then because it's a forward-only read stream, once you read those bytes, you can't just rewind on a network stream. So you have to essentially buffer those into a peak buffer, and then you have to pump that message into the destination as well, so you don't lose them. But what it does is it reads the headers here, and that logic is not super complicated. It simply goes down and reads and copies every line. Which looks something like this. Has a string builder, does a read byte, waits to see if it's character 10, which is the new line, and then if it is, then it's done with that loop and it knows it's the end of the line. And then at the same time, it goes ahead and it writes that into the peak buffer stream. So that way we read and copy at the same time.
Right, because you have this problem, I guess, where as the connection comes through, you need to know where to route it, but you don't actually know until you've read the headers and looked at the cookie and determined that. So you're buffering this up. You're not sending it anywhere. Right. You're first just sort of reading through, looking for that cookie, but keeping everything. So that once you establish the connection, you can send all that stuff you buffered and then continue sort of piping.
Yeah, exactly. So you send what you buffer, and then you kind of snap together the two connections, and you do an asynchronous copy between them. And that's exactly how it works. So in the case of this sticky session mapper, we read the headers, and then we actually go in and let's take a look here. We try to get the cookie value out, and we do a quick search for the ASP.NET session ID. If we find that, then we have a little method in here called lookup endpoint, which is really, it's looking into a hash table and saying, have you seen this cookie? Was it this endpoint?
Right, so in memory you have a dictionary there that says this session ID means that specific instance, and it's that instance by instance ID? Is that, or is it actually IP address?
It's actually IP address.
It's actually IP address, okay.
So it was already resolved, the remote endpoint, and then it's just going to store that.
Right.
So that's really what it is. Then the final bit here in the TCP router is after we kind of figure out where we're going to go, so we get that remote endpoint, what we do is we snap together the sockets, and here's the magic code, which is go ahead and forward the two streams together.
Yep.
And this forward stream, like I said, it does an asynchronous kind of buffered stream copy between the source and destination. And then from the user's perspective, nothing's changed. They're just hitting this, what appears to all the world to be a valid HTTP server, but under the covers, it's just forwarding it to the real server and then taking the streaming bytes back and sending it back. So nothing appears to be odd for this. Now, to see how this works, I'll just go ahead, hit F5. And what we'll do is we'll deploy this here locally, and I'll kind of show what that looks like. There's some other code in here. I'm not going to go into too much detail until we get to the tip of the week, but there's some other code and some false starts that I had in developing this.
That's why we do this stuff, so that we can find these issues.
So the development environment's up and running. I'm going to go ahead, open up a new IE, and what I have is on localhost port 81, this is going to look really interesting, right? This is the default website.
IE didn't open by default when you hit F5. Is that because you have a TCP connection for this Okay,
That is why. So
that's what I assumed, but actually that's a.
So let me show you.
We've talked about the differences between HTTP connections and TCP connections before, and I can understand why you need a TCP connection here because you actually want you don't want HTTP sys, you want to actually listen on the socket directly. And one consequence of that people don't always realize, like when they're running Apache or Tomcat or something like that, is that means that IE won't automatically pop up. We won't automatically launch a browser because we look and see, is there an HTTP endpoint? Oh, there is. Okay, launch a browser.
Yep.
And in this case, there won't be because it's a TCP endpoint.
That's correct. If you look at my web roll, I mean, this code is like literally I've done nothing to this code other than add a little bit of session into it so that we could, for demo purposes, show that session.
So we can see it's working.
There. Yeah,
it'd be a great demo if you just said, "Look, it's a default page," and trust me, I'm always hitting the same instance.
Exactly. So I didn't do anything other than add a default ASP.NET web project. Now the other stuff that I did in here is really the routing worker itself. That is a worker role.
Yeah.
And if we look at the configuration for these things, you'll see that all I did was set up an endpoint. I called it HTTP. I put it on port 80.
Right.
And that's it. And in the web UX, what I did was, you see I have the input endpoints HTTP and HTTPS turned off, and I have an internal endpoint for HTTP called internal HTTPN. So there is no exposed endpoint on the load balancer for my web role at all. The only thing that you can talk to...
The entry point is always this router.
Yeah, the only thing you can talk to is this routing worker. So the fact that, I know it wasn't super impressive when it first showed up, the fact that you're getting HTML back, talking to a worker...
is actually kind of...
is kind of cool
by itself, right?
You're
because
like, wow, that's
all
awesome.
this is actually getting routed through an intermediary, which is examining the TCP connection and routing it to somebody else and sort of forwarding things back out. I guess for people who develop proxy servers and things like that, they're used to this. But for most of us, this is actually fairly unique kind of setup.
Yeah.
And so is it working? How do we know?
Well, what I did was I put in a little bit of session here.
Yep.
So you last visited at a certain time, and then I have the name of the instance that served it. And this is, since I'm running in local dev fabric, it looks a little bit different. But if you see, that's actually working.
Right. So now, that means we're always coming back to the same thing.
We're coming back to the same thing.
And the session state is not, we talked about how to deal with session state in sort of the stateless scale out way in the cloud, but that's not what you're doing here.
No, this is improc.
This is improc, the default ASP.NET session state, which means that if you weren't hitting the same instance each time, you wouldn't have session state. You'd land on some random instance that had never seen you before. It would get this cookie that had a session ID that doesn't exist, and you wouldn't be able to see this. So, so that is actually an interesting use of this. If possible, I'd say it's still a good idea to centralize your session state in a SQL database or in Windows Azure storage. But using this to sort of put in-proc session,
if you can get away with it, it's a neat trick to do, right? If session's not critical to your application, you don't care if if this connection goes down, but it's just an optimization. This is perfectly fine to do.
Yeah.
What I have here now, that was running in the dev fabric, which, as I said, is not that interesting. But what I have here is I have up in one of my accounts, I have the routing worker, and then I have a web UX with the 3 instances running. So when you hit this website, and hopefully this works, oh, there it is, you see that we're getting routed to web instance 0 in this case, which is the first instance. And then every time we hit refresh, we're still there, and you see how my session never changes.
Right.
If I go check and I click the pages and I start going through the different things, you'll note that I'm always hitting web UX instance 0.
Right.
It turns out you can get other instances, but to do that, what you need to do is you have to go into safety, you have to delete your browsing history, you don't have to do your history, but you have to do your cookies.
But you have to delete the cookies, right? Because the cookie is the magic thing that the router worker is looking at to decide where to route me. So if I don't have a cookie, then I'm coming in fresh. Now, this is always hard to demonstrate because...
It is, because I could get rerouted to instance 0
right,
anyways.
you might randomly get the same one, and the fact is that keep alive TCP connections, which you're using here, and the browser uses, the browser tries to reuse connections here, and so you actually, even if you're just testing out your sort of load balancing in Windows Azure, just hitting F5 over and over again in the browser is unlikely to actually land you on different instances because there's a good chance you still have that persistent connection open.
Yep.
And you're actually going to piggyback on that same TCP connection, which means it's not newly going through the load balancer and getting randomly spread out. It's going through that load balancer back along the same connection you already had open. So it's notoriously difficult to demonstrate this. Are we going to try anyway?
Well, what I wanted to actually show here, I've opened up TCP view from sysinternals, and what I'm trying to show here is if these connections.
So it's brought to us by Mark Rasinovich, who is now on the Windows Azure team.
Exactly.
Just a little plug for Mark. It's like the third time I've come across one of Mark's tools since he joined the Windows Azure team. I always email him every time it happens, and I go, "When are you building these for Windows Azure?"
So the reason I did this though is because, and let me shut down the dev fabric so some of these connections go away. The reason I did this is because I wanted to actually show that I have a connection. Now we have a proxy server here, which is the problem. So you can't see me connecting directly to the website.
Right, because we're always going through
the
Microsoft
through the proxy
yeah.
and then on. But when these connections go away, if I come back to the site, and let's see if we get a different instance this time. Now still instance 0. Unfortunately,
yeah.
So it's where a couple things probably happen is either the proxy sending us to the same has the same TCP keep alive going, or we just happen to within
there's like a 1 in 3 chance of hitting the same one anyway, and so it's sort of all these things add up to make this.
But
this
the point is
Ryan wrote code that always routes it to instance 0, and he put all this fancy cookie thing, but it doesn't actually do anything.
Yeah,
that's
now I guess the other part that we should probably talk about before we get to the tip of the week is astute viewers will say, well, haven't you just pushed the problem forward?
Do we have astute viewers?
I think we do. We have at least 2 of them.
Okay, we've got at least 2 astute viewers.
And what they're going to say is, well, you have a single instance of a routing worker.
Yes.
And it's doing something in memory. So you're putting state on your router.
Right.
Is that dumb or is that smart? And the answer is, it depends, right?
No, the answer is it's dumb.
Sometimes it's dumb. Sometimes it's
well, I
dumb.
mean, a single instance of anything means that you are subject to downtime,
Yeah.
right? Anytime you go to roll an upgrade to this, it's not going to, for a while, there's going to be no router up, right, during that reset.
Exactly.
Which means no traffic's going to go anywhere. So I would put this
worse,
in the dumb category.
In this case, if I had 2 routing workers, because I have an in-memory dictionary.
Yes. And if you have 2, you've got a 50-50 chance of actually hitting something that knows which server to route you to.
Exactly. So you're going to get routed differently.
Yes.
You're going to have sticky sessions.
You're going to get sticky sessions on both, which may happen to be, if you're lucky, the same instance, but probably won't be.
So you're going to either have to synchronize the state or externalize it again into table storage or something like that. Or, now here's the clever one. Now for HTTP this works, for other connections probably not as much. What you can do is you can actually inject a cookie on the way back. Right. And so if you remove the state from the actual instance itself and you make the client tell you where it came from, then you're automatically stateless at your router, and this whole problem's solved.
Right, because we sort of have this level of indirection now, because you get a cookie and it says some session ID, and then you look up what server to send it to.
Right.
And what you'd really like is if there was just some cookie that said the IP address that you were trying to reach.
I just came from this IP address.
And we can make that happen, right? I mean, the idea is, well, you could just inject a cookie on the way out that said specifically that said, I want to be routed to this IP address. Then put all that stuff's on a client, and as long as the client has that cookie, which it will, right? Then you'll be able to route in a completely stateless way, because you're getting all the information from the stream itself, the incoming HTTP request. That sounds like a decent way to make this thing scale out.
I actually put in a little injection point here where I know if I was going to do this is kind of where I would do it, but I didn't implement it yet, just because I didn't have time. I was screwing around with this. So
we're getting bitten by what we're going to talk about in the tip of the week.
Yeah, exactly. So what I have here is, for the first part, right, we're taking that peak buffer and we're slamming it into the destination, which is kind of our incoming twiddle with the stream. Right. And then we go ahead and we forward the rest of that stream. And then if we wanted to, what we could do is we could start a read from the destination back to the source. And part of that read was we would look and we could set cookie header. We could just go ahead and add that into the connection. Right. And then send that along. What will happen is the client will then set it, and every request that comes back will have that cookie in it, and then you're statelessly load balanced. Clever, easy thing to do in some ways. This is a little more complicated in others, but it's a handy trick to have. Now, that leads us to the tip of the week.
Yeah, so I thought as an intro for this tip of the week, we should see Ryan's family of routers helping us to introduce, maybe coming to this country.
Router McDougal's.
The Router McDougal's.
And the Dunn clan of routerness.
So let's let Bob sort of take a shot at that.
No idea.
have fun with that one, Bob. Here is your tip of the week. All right, the Router McDougal's.
There they go.
And so
I don't even know where McDougal comes from. It's not even done.
You just sort of put that on the end. I have no idea why, but
it's like Shooter McGavin.
It's hyphenated though, right? Like Router hyphen McDougal.
Yeah, maybe that was the original clan family name.
I assume. I see how that could get translated to Dunn.
Yeah. So
so how's that routing going? I'm done. There it is. Ryan Dunn. The origin.
All right, man. So let's talk about the tip.
Yes.
Here's a tip. It all boils down to this. Stuff works locally and doesn't work in the cloud. Why is that? and here's what I found out.
Right. So there are lots of different flavors of this, but here's one.
Specifically what happened. So my initial plan when I developed this actually was I created a service host, and the service host is literally a command line program, static void main, that starts the TCP router and sits there forever.
Right. So an executable. So this is like a console executable.
It's a console app. And the reason I did this was because it's very clean in that way. Your role could start this up, right? And then it's outside of the role, it's externalized. So if it crashes, it doesn't take your role down.
Right.
Plus, you can hook the exiting event. If it crashes for any reason, you could just very quickly start it back up again.
Yep.
And you'd have essentially uninterrupted service.
This is a lot like what we did. Remember we did that episode way back when where we put Mongoose, this tiny little web server, in a role, and that's exactly what it followed the same pattern. Same thing for Tomcat and for MySQL and for pretty much everything, where it's like, well, look, those exist as standalone executables. We'll just launch them and then just monitor that process and restart it or just die if something goes wrong. Seems like a good idea.
Yep.
Now, what happened, Ryan, when you tried this?
What happened was this worked awesome locally. And you would see a little console windows open up. In fact, I had originally put tracing in there so I could just see the headers fly by as the connections happen. It looked really cool. And then I went to deploy it to the cloud, and it was never on.
Yep.
And I used IntelliTrace and did all these things, and you really don't get very good error messages from processes that are launched. Like if it's in your code, you get awesome error messages.
If it's spawn process.
But a spawn process, when it crashes, IntelliTrace doesn't know about it because it's not part of the PDBs and everything like that. So I didn't get very good error messages other than the fact that it wasn't on. And I was like, well, that's weird, right? So let me try getting better error messages. I'm going to pull out what the exe's doing and put it directly in the role. Went to go do that, and it worked. So, well, what is going on? It works if I run it directly in the worker role. So in the worker role here, you'll notice that I have this code that says router, new TCP router, here's the stuff. And I commented out this other code that said launch router, which literally started a process for the routing service host.
Right.
One worked, the other didn't. It turns out.
What I like about this is that this problem is common enough that when you described that much to me, I had my first guess was actually the right one on this. Which is, my question was, well, are you using the role environment or using the role API in that spawn process? And it's because I knew about this particular gotcha, which you will find if you look carefully in the MSDN documentation.
Yeah, it says currently Windows Azure does not support calling the Windows Azure managed library from within a subprocess.
Right.
That is the actual problem. Because I need this initial sticky load balancer behavior, the process itself needed to call and get a random one.
Right. So it had to discover the IP endpoints of these things or whatever, which requires calling the role.
Right. And the only other way to do that would be to have a service on the role itself that shared this information with the process and did some in-process remoting or shared file mapping. That's kind of messy. So it's easier just to call the library. And it turns out you can't do that. Now you can p-invoke but you can't call into
This
the
is
native.
this is weird to me because I don't actually understand the underlying reason why you can't do
There
this.
must be an app domain singleton or something. The only thing
It's
I'm
got to be
thinking of.
something like that, right? That basically, you can't do this from .NET, but you can call the native API, and of course you can do that from .NET using pinvoke. And it seems like that's what calling the managed API would do. So there's something that I don't quite understand that process, but you can do that. So I suppose that's one workaround for you is you could pinvoke into the native runtime API.
Exactly.
But putting it just directly into the role seems like a decent way to do it. So the point here is if you're spawning processes in Windows Azure, now commonly you're spawning those processes because they're not particularly Windows Azure things, and so you're just keeping an executable as is. So they're unlikely to be using the runtime API.
Like using the Python for Swingify.
Exactly, right? And that stuff is not calling the managed runtime API, so it's
wouldn't be
okay,
working.
so you don't have to worry about it, right? But if you're developing your own process that you're going to spawn in this way, you do need to be aware of this this issue where you can't use that runtime API. One thing that I've done before is I often just need to get some configuration setting or something like that, and I just pass it as a command line parameter. If you're building your own process, it's sort of easy to do that thing. Not as easy for network topology, like in this case, because that changes over time, and you actually want to. You don't want to just start up the process with some list of IP addresses and that's it, because you're always, those IP addresses are changing, or you're scaling up or you're scaling down. So for network topology, I don't have a really good clean. So as Ryan said, I mean, you could put these in a file that you can share the data in a number of ways between the two processes, but there's nothing really particularly clean and easy to do for that.
Not at all.
For very simple configuration, like what port should I start listening to, a command line parameter is a great way to just pass that information. Only if it's static enough that you can really live with that. So so that's the tip of the week: is don't use that runtime API.
Within a spawn
process.
Or
at least don't use the managed API.
Or if you're trying and you're wondering why it's not working, that's
now
why.
you know, right.
Now you just go through the pain that I had, which is, why isn't this working? Why isn't this working? How come it works if I put it in the thing? And then, well, there's some other reasons why I thought it would work that we won't go into, but
there are other potential issues here, but that's one of them.
So then Steve's like, well, you're not calling the API, are you?
Yeah. So.
Yeah, that was it.
Yeah. So just does show it comes up. I've heard this issue a few times. I've run into it myself. That's why I knew
my
about
ancestors
this thing,
didn't have this problem back in the day because there wasn't the cloud.
No, they were routing manually.
They're manual routers across the country. Go that way.
Yeah, you go that way. You go that way.
Go.
You went that way last time. Keep going that way.
Yeah.
Okay, with that, I think that's going to do it for this week. As always, if you have something that you'd like us to discuss, or you have a question about something we did, or you got some cool news that has links to our episodes in it that you'd like us to share,
or you have something free you want to send us, or logoware,
let us know by sending us a message to @CloudCoverShow on Twitter, and we will definitely take a look at that. So until next time, thanks.
Thank you.